Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
And we're back with our image classification mini-series or detour or whatever you want to call it. We're back. We just quickly did that Israel-Gaza night lights video tutorial, because that was a request from a number of subscribers. And just to see whether we can do what we've done in Korea, in Ukraine, Russia, for Israel and Gaza as well. Okay, so we're back. In 183 and 184, we applied the Jetsaka tool. In 183, we generated our images, our classification images with the Jetsaka tool, and there was 4 of them. And then in 184, we tested them. We tested the tools or the classification for accuracy based on the built-in functionality within Jetsaka. Okay, so all that is done in QGIS. There's our Jetsaka. Remember, it's this little magnifying glass, or you can go to plugins, Jetsaka, there, and go to the dock, as I said. And we've abused all 4 models. There's a 4, 1, 2, 3, 4. We've done all 4 models, classifications. There they sit. There's the 4, the Gaussian, random forest, support vector machine, k nearest neighbors, and then we rerun that with confidence levels and confidence maps, all of them. Okay, so that was done, and then, as I said, we generated the information in Excel to say, okay, within each of these methods within this tool, what's the pixel count in the square area? 4, 0, 1, 2, 3, 4, 5 classifications, 1, 2, 3. 1 being water, 2 is veld, 3 is mountains, 4 is agriculture, 5 is urban, and 6 is bare soil or sand. Okay, and you can see the differences, whereas the Gaussian is fairly different. The KNN, k nearest neighbor, support vector, and the random forest seems to be more in line with, I would think, the random forest being the more accurate one than these 3. So intuitively, random forest seems more accurate, and the only reason why I'm saying is because of the urban, the size of the urban areas, because we know urban areas is a small portion of it, and if you look at water, is a bit more, etc., etc. So that's intuition, knowing my region of interest. So the next one that we're going to do is this one here, which is called the Supervised Classifier. Okay, Supervised Classifier. It's a plugin, so you just go to plugins, manage and install plugins. You go to all and you search for Supervised Classifier, and there it is. Okay, there is its homepage, its bug tracker, code depository, and there's all the ins and outs related to the specific plugin. Okay, it prides itself on being user friendly, easy to use interface, blah 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 blah, and the tools that we're going to do is minimum distance, random forest, support vector machine, and also working on as well. So that is not yet up and running. So it's got the 1, 2, 3, 4 tools, 4 methods within the specific tool. So let's open it. So we're going to go and left click on the tool itself, and we see the methods here. It's distance, random forest, support vector machine, and k nearest neighbor. So roughly the same one. It doesn't have the Gaussian one, which the Jetsaka has. The random forest, the Jetsaka's got, and this tool's got. Support vector machine, both of them got, and k nearest neighbor, both of them got. The supervised classification have a minimum distance tool, where the Jetsaka has a Gaussian tool. So that's basically the difference. iterations. You want to save the train model, number of iterations. There's some options that you can do there. Specifically with your random forest, iterations is quite interesting to see what the differences there would be. Okay, so it does not have options to do confidence maps and to look at training and sampling. So it lacks that functionality. Where in Tut186, it's got your option to create confidence maps to determine where the errors lie, which pixels are misspecified. This particular tool does not do that. Okay, so let's get going. So we're going to do browse. So in this case, in here, image is our stacked raster image, our bands, our daytime image stacked for all the bands. So I'm going to go browse, and it's going to take me to my image classification, and I'm going to find that stacked Sentinel stack raster. There it sits, which is basically this one here, which I've also used for Tut186. That is my Sentinel image with all 12 bands stacked into one raster. So that's the one that I use. Reference shapefile is my training file. This training one here. Same one that we used in Tut186. So I'm going to go browse. There's my training. So I open that. Same one. Output folder is where I want to save it. So I'm going to go browse. I'm going to save it in my image collection. It does not give you the option to name it. Just it names itself. It gives it its own name. All you have the option is to say where you want to save it. Okay. Then minimum distance. So we can choose minimum distance. We can see random forest. You see when you do random forest, it opens that number of iterations. Support vector machine, also number of iterations. K-nearest neighbors, also the number of operations. Maximum light look is not yet working. I didn't try that. So minimum distance, there's no parameters to select from. It is what it is. Random forest, there's one parameter, which is the number of iterations. Obviously, you want to the image classification to be automatically added to your layers panel. So that's why you will click that. If it's not, then it won't automatically, and then you have to go and find it, bring it in, etc., etc. So we just click that. So random minimum distance, random forest, support vector machine, nearest neighbor. As I said, you have your stack raster of your virtual raster. You have your training file with your training samples for each class of classification. You have the place where you want to save it. And within your training file, we use the ID 1, 2, 3, 1 for water, 2 for this, that for 3. It almost must be a numerical number. It must be a numerical number. And select. And then you just press classify, and it will then classify. Okay, so I've done all of them already. I've done the minimum distance, I've done the random forest, we've done the support vector machine, we've done the k-nearest neighbors. As I said, select it. Make sure you want to, for example, again, I want to keep the trained model, want to save the trained model, and I'm leaving the iterations as a default 100. Okay, and then it just say you just classify. You just press classify, and then you just leave it for QGIS to do the rest, for the plugin to do the rest. Okay, go make a cup of coffee, get a beer, whatever the case might be. It does take a bit of time, and when you get back, hopefully it has classified. Okay, so that is the supervised classifier tool within QGIS. Okay, so we've done all 4 of them. We've done all 4 methods. We applied all 4 methods. We keep the parameters. We keep the parameters as it is specified within the tool itself. We haven't changed any parameters. So if it says iterations 100, we leave it at 100 and vice versa. Okay, so let's have a look. Let's have a look. And there it's called. Remember, it doesn't allow you to give it a name. So when I import it, I change the name. Okay, so when I imported it, or when it's opened here in my layers panel, I just go right click and I go to rename, and I name it what I want to call it, or what I want to name it. Okay, so there is our minimum distance classified image. So Zetsaka, I all call Zetsaka. This tool, I all call my images, my classified images, I call them all classified image. There's minimum distance, there's random forest, there's the support vector machine, and there's the nearest neighbor. Okay, so let's have a look at that. So there's my minimum distance. Now, for whatever reason, this background, it also classifies as water. And I'm not sure whether it is just how it normally does it. It's the first time I've used it. I cannot, so if you go, for example, in here, properties, then that is not a 0 value. It's a 1. So if I click on this little information button, I click on it, you see it gives me 1, which is exactly the same as my water. See, water is 1, and this background is 1. So why it's doing that, I don't know, but that's not very good. So I would assume if I made agriculture 1, then this would be the same as agriculture. So that just skews the whole thing a bit. So just bear that in mind, that the first class seemingly will also be the value of the background. So just bear that in mind, etc., etc. So we know what the size of the background is, and that is that size. So we can always subtract it, because in the Zetsaka, it does classify for 0. So for example, if I go to Zetsaka, you'll see if I go to, let's say, the Gaussian one, there's no background. However, if I just go classify, you see there's a 0. And if I go, okay, you see there's my background. So we know that the two backgrounds, if I go to minimum distance here, you can see the two backgrounds exactly the same. So we know what the size of the back, so we can always subtract it. It's not ideal. That's not what we want to do, but that is what we are giving. So load style. So I just want to go back to this one and do what we are supposed to do. So open a load style, classify, and apply. Come on, and okay. And there it's gone. Okay. And the reason why it's gone is because in this case, this background, this outline, the square is all zeros. But for whatever reason, in this classifier, it has the same value as the first class. Fortunately, as I said, we know what the outline is, so we can always subtract it. Okay, so there's my minimum distance. Lots of red again. You can see there. There's a lot of misspecification here. I think that the agriculture seems to be correctly, the water seems to be correctly specified, the mountain seems to be correctly specified, the veld seems to be correct, the river. So all of the classes seem to be fairly correctly specified, except, and it's come back to all of my classifications, is the issue of the problem with bare soil and urban, that their spectral signatures are so close that it's really a struggle to effectively differentiate between the two. And that's again why your training file, your classes, needs to be spot on. Anyway, so there's my minimum distance. Let's have a look at random forest. There's my random forest. The random forest has much more agriculture. Still have these bare soil areas, but it seems to have less misspecified pixels locations than the minimum distance. So let's have a look at a support vector machine. Now that looks, I mean, you can make up your own mind. That makes no sense. I mean, basically means 90% of the area is urban. That doesn't make any sense. And then the k nearest neighbors, there's the k nearest neighbor. So in this case, support vector machine seems out. And minimum distance seems to be out as well. So support vector machine, minimum distance, so it's between random forest and k nearest neighbors. Interestingly, the difference between this, so in Zetsaka, the support vector machine actually looks very good. However, in this classifier, the support vector machine looks terrible. Absolutely terrible. So let me just save again. So there's my 4 image classifications based on the Supervised Classifier plugin within QGIS. Now, as I said, it doesn't have the ability to generate confidence. However, we can rerun, for example, random forest, because in this case, we did a random forest with 100 iterations. We'll do a random forest now with less iterations to see whether that's a little bit more accurate, to see whether the iterations, that parameter, is important in terms of the accuracy of our image. So I'm just going to do it for random forest. I'm not going to do it for the others, but one would assume if it does have a significant effect, it will be relevant to all of them. Anyway, what we first want to do is to generate the statistics. Remember, in the Zetsaka we created the spreadsheet to say for each of the tools what is the associated numbers. So I'm just going to copy this, and I'm going to copy. Then we're going to paste it in here. Sorry, let me paste it as the format, and we're going to say this is the classifier. The classifier method. So, and I'm going to let's see. Why is it doing this? Caps lock. Classifier method, and we have the minimum distance. We have I'm going to leave the others at the same places because it's also k nearest neighbor, support vector machine, and random forest. In this case, our random forest, I'm just going to make it as 100, meaning there was 100 iterations in this random forest. Also with this support vector machine, we did 100 iterations. In this KNN, also 100 iterations. Okay, so minimum distance, we want to get the numbers for all of them. Okay, we want to get the numbers for all of them. Okay, so we're going to go back into our QGIS. We go minimum distance, our unique layers, unique values report, unique raster layer unique value. Sorry, that's a long word, but there we go. So we're going to go minimum distance first. That's it. And I'm just going to run. And there it sits. So we're just going to go open it, copy it, and you see there's no 0. There's no 0. So we will have to do that 0 manually. See, here's a 0. We'll have to do that 0 manually. So I'm just going to paste it in there. Let it sit. So it's 1. So we know that from 1, and that will be, so I'm going to assume that these values are the same, okay, as with the Zetsaka. So this value will be equal, it will be 1 minus that value. And then it's at 4,700, which is fairly accurate. And I'm just going to do right click there. Oops, sorry, it doesn't want to do that, because these are points. It doesn't like points. My computer doesn't like points. I'm going to go, because it sees points as language, not as numbers. There you go. And then the rest, I'm going to copy as is. I'm going to copy as is. And there we go. You'll see urban. Urban is 5, urban is 5, minimum distance. So I just want to quickly just make sure that I got my, okay, so I'm just going to do this. Just the semantics of it. I don't want it different, just make it different fonts and things. I just want to make it all the same. And then this one as well. exactly the same. Come on. Here we go. And then I'm just going to take this formula out. And I'm going to put the numbers in. Because if I put new information in there, then obviously that will change. So it had 4,700 for water, which seems okay. Agriculture 88,000. Veld, it's got less veld. And then you can see it has similar urban than the Gaussian. And okay, so that's minimum distance. So let's quickly do the same for random forest. Let's do the same for random forest. Run. And we're gonna do random forest. And copy it in there. I do the same. Take this dots, get rid of it, find. It's already in there, so replace all. And hey, come on. And then this is random forest, so I must remember to put it in there. So that will be equals that value minus that value 4,500. And I do that. And then the rest I just copy and paste in there. And paste. And there we go. That is, paste these ones. It looks very, so the random forest 100. So the bare soils has got very similar, but it has much higher urban than the random forest here. The water seems to be the river, the water seems to be very similar. The veld seems to be very similar. Mountains is similar. You can see there's a bit difference in the agriculture. Okay, so there is slight differences between the two random forests, but in general it seems fairly similar. Let's do the same for, we've done minimum distance. Let's do the same for image for support vector machine. Run it. There's our support vector machine. And we can, sorry, you see pixel count 799,806. 79806. So that's why I say the pixel counts are exactly the same. So in this case again, so this is support vector machine. So it's going to be that one. Sorry, that is going to be, oopsie, sorry, I've already, you see, I haven't done, didn't do that. Change that formula to values. And now I'm going to just paste it in. Sorry, I need to go back now and get that values, and we're gonna, hey, come on, we're gonna paste it in. Just get rid of the dots, finally replace with commas, and this is a support vector machine, so it's that one there, so it's equal, so it's that value minus that value, and we just drag to the right, and then we just copy these values in there, and I'm just going to do the formatting of these cells, and there we go, and then get rid of the formulas and replace it with the values. Go back there, and then it's our last one is the k nearest neighbors. We haven't done that one, and there it sits. That one there, comma, go to my Excel, paste it in, get rid of the dots, replace it with commas, and then that's the support vector machine. Go and say equals. It's going to be this value minus the zeros, and I'm going to drag it to the right, and then I just copy all these other values in there, and then I just format the cells, and I copy and I paste it with the values itself. Now I can delete that. There we go. Let's have a look at the k nearest neighbors. 4471, 49 187, 117, big difference. 57, 59, very similar. 106, 112, look at the urban, big difference. Let's look at the support vector machine. 5, that's very similar. Ooh, look at that. 2 and 165. And look at the 240. That's why I'm saying the two support vector machines are very different. So seemingly the same methods yields very different results when it comes to the different tools. But let's quickly check. I mean, the difference could be because of the iterations. We don't know what the number of iterations within ZSAKA is. It doesn't say. So let's have a look and see. Let's do the random forest one. Sorry, let's do the random forest one. So first of all, select my daytime image. The band stack. Let's select my training, my output, and then I'm going to go with random forest, and here with iterations I'm going to make it 10 so that it is significantly different to 100. Otherwise, if you make it 90, I mean, what's the difference here? So either assume 100 is fine, or make it some significant different number so that the results supposed to be, because if it's not, the results are not significant different between 100 and 10 iterations, then it's not gonna, then the number of iterations doesn't matter per se. But the fact that they've put it in here means that maybe it has to have an impact. So let's say classify, and now we wait. Now we absolutely wait. How long it will take, who knows, but let's leave it. So while we're there, so we've got the classifier, and obviously we're going to build on this, so at the end of the day we're going to compare them, we're going to rate them based on some arbitrary evaluation. For example, 240 pixels, this is 3.69 square kilometers, because 3,694 square kilometers. Or is it 3.6? Must be 300. You divide by 3 zeros. Now that makes no sense for the amount of urban areas. Because if you just look at the image, okay, let me not hana with the image now because it is thinking. It's not responding, but don't worry, it should work. That's what I'm saying. Actually didn't want to hana with the image now. So let's stick with it. So let's quickly pause there. And then we'll be back as soon as the classification is done. So let me quickly pause. Cool. So eventually, I think it took, what did they say? Oh, they did give an idea. They said 86 seconds. Oh, there we go. 85 seconds, 10 iterations, etc., etc. Class distribution in training data trained, model accuracy 1. And class distribution in training data 4 to 10. I'm not sure exactly, so I presume it's 4 and then 3, 0. Most probably 4 has got the most, yeah. So 4, which is agriculture, has got the most, followed by 3, which mountain, I don't know. And 0, it's got a 0 here, I don't know why it doesn't. Anyway, so let's close it. There it is. So that's my classified, so I'm just going to rename it. I'm going to rename it classified image. I'm just going to get rid of that classified image. Random. Sorry, not random. Hey, random forest. And I'm just going to make it a 10 because we had 10 iterations. Okay. Let's give it the necessary style. So remember, we just go to style here because I already saved a standard style. So I go there, and we go our classes, our style for our classes. We load the style. Okay, close, and there we go. So there's the 2. Well, there's the 10, and there's the 100. Let's have a look and see if there's big differences. So the 10 seems much more red, where the 100 is much less red. You see, the 10 is much more red. 100 is less red. So looks like the more is better. So let's save it and let's do 500. iterations 500, save. And let's do iterations 500 and see what that looks like. So we're going to go browse. We're going to go our band stack. We're going to go our reference shapefile, which is our training. We're going to go and browse it. I'm going to just select that folder. ID. We're going to go random forest. And then we're going to go 500. And I want to open it. So let's see that. So classify. Let's classify. And it's going to take, what did that other one take? 85 seconds. This most probably will take longer because it's got 500 iterations to go through. So again, let me quickly pause there. And as soon as it's done, I'll come back to you. Okay, so just hang on. Cool, so this was done. And you can see it was done in 334 minutes. Remember, the 10 was done in, 86 minutes. This was done in 86 minutes, 86 seconds. This was done in 334. So that just gives you the difference in iteration. So the more iterated, the longer it will take, etc. So let's have a look and see. Okay, you see there it is. The 41037, that looks exactly the same. So let's see what that looks like. So I'm just going to call it, I'm going to just go rename it, image, classified image, and then random forest 500. And let's then apply the style. Okay, style, load style, and I go and find my style. Say open and load style, and okay, and there it is. So there's 500, and there's 10, 500 and 10, 500 and 10. So 500 is definitely less red, where 10 is more red. So I would think more iterations is better than less iterations. What is the optimal number of iterations? That's obviously a bit more tricky to say, but visually it does suggest that more iterations is better than less iterations. Now obviously we'll have to also add those values into our data set so that we can compare them. So let's quickly do that. Well, before we go, let's take the 500. We already said the 500 seems better. So let's quickly do the 500. Random forest 500. Let's run it. Just quick before we conclude. And there it sits. So let's quickly have a look. I'm going to go back here. I'm just going to paste quickly the data in there. And then just going to go equals that value minus that value for, and then okay, remember what I just need to now get rid of the dots. So that is water. I'm going to go copy, close in. So let me just get the same format. It's just easier to compare with the same format. Okay, so 434.5, 122, 123. So that's felt. Does have more felt. Mountain, very similar. Agriculture, a little bit less. In this case, it's got more urban and not less urban and stuff. But you can see it's very, very similar. There's not huge differences between the ones. Visually it just looks like that 500 seems better, but in fact it does not seem to be like it. So maybe 500 is over specified and 10 is under specified. Maybe something more like 250 might, or something to that effect, would be more accurate. But it's not, okay, sorry, it's not making a huge difference. It's not changing the world. It's not to the degree where I would significantly change necessarily my iterations. As I said, it looks here and there a bit different, but those are the margins. It doesn't seem like it's big. I'd like the 500. It visually just looks better, but okay, so there's the original one. There's the 500. There's very, very little between the 500 and 500. You can look at that. Visually, there's very, very little. The 500's got, yeah, visually that's very, very little forest. It has a little bit more forest, although it's not a, it's actually, it says less, but it looks like there's more. Whether I would necessarily change anything because of the iterations, nope. I wouldn't be too concerned about the iterations. I would be fine with leaving it as 100. So I would assume the others would be exactly the same. Okay, so let's save. So that is our supervised classifier. If I have to rate it, I'll definitely rate it below Tetsaka. I think just intuitively, the results from Tetsaka, not all of them, seems on the whole, on the average, the result seems a little bit more plausible than the image classifier. Also, the image classifier with the accuracy assessments, it doesn't seem to work. So, good tool. Nothing wrong with it. I don't think it's better than Tetsaka. But again, let me make the caveat. It's for my region of interest, for my particular period in time, etc., etc. It may be the case that if we use a different region of interest at a different time, it will perform better. So always make that caveat that it is for this particular scenario. It doesn't mean it's every time always will be the same. And that we have to test at some point to look to see whether if we have a different region of interest, whether there's going to be different results. But anyway, so that is the image classifier, a supervised classifier tool within QGIS, using the 4 methods and playing around with the parameters or the iteration parameters to see whether there's a significant difference or not. Cool. So that's our second set of image classifications. Done, dusted. Let's save and let's start focusing now on number 3. And we're going to most probably use the classification tool and look at that as our third tool to see what we can learn from that. Where does that fit into the pecking order? Okay, so with that said, boys and girls, thank you again for joining me. Please remember to like, subscribe, share the video, press those buttons, make it happen, and I'll see you on the other side.